Now, on the topic of measurement of emissions, methane is particularly difficult to measure. There are massive discrepancies in methane emission estimates, and these discrepancies exist at the national level and also at the global level. The key message that emerges from this particular figure is that Saudi Arabia and the UAE are the top performers in the region. So those two countries have significantly lower methane intensities for their oil and gas sectors compared to their other Arabian Gulf countries.
We have learned that almost always, not always, but almost always, there are more emissions than we thought there were. Reported emissions are almost always underestimated. And when you look at the United States, where there's probably been more studies done than any other place in the world, the scientific evidence shows that we're underestimating emissions by about 60% in our reported emissions. There are still discrepancies, though, in all of the data. And I think the important thing about data is we constantly want it to improve. It will never be perfect, and so we have to act now.
And that's been a big theme for methane emissions this year, transparency. So the move towards more transparency when it comes to the measurements of emissions. Timeliness is another big advantage, because with satellites, you can have a measurement of methane emissions from just an image that was taken a few days ago, taking into account the time that you need to process that image. So timeliness is a big advantage. And I think when it comes to accuracy, satellites can deliver a lot on accuracy, especially if methane emissions are measured using activity data and a default or an average emission factor that's not being measured. I think that can be very inaccurate.
Local sensors, there's not that many of them by definition. They're on the ground. They often sometimes can detect emissions. Sometimes they can't see the emissions. They almost never can measure the emissions. You really need to have a view from space to measure the emissions. Even aerial surveys or drones can detect emissions, usually not very well measure the emissions. There's limitations in measurement. Satellites typically are the best in measurement. They're the best in detections, and they're very good at detecting supermeters that are very distributed geographically. I mean, there are some facilities that are chronic emitters, but supermeters are very brief, very intermittent. By definition, they are missed by aerial surveys or drone surveys that can only happen once a quarter, once a year. That are very expensive. So there are things that we see with satellites that we cannot measure otherwise. So how do you prove the accuracy of these measurements? One approach that's been adopted has been to organize controlled releases of methane.
Let me just first say, we don't actually have that choice. We don't have the choice of picking a sector to reduce emissions. We have to reduce emissions in the oil and gas sector, the coal sector, the waste sector, and the ag sector. When you look at what we can do quickly, it's oil and gas. That's what you can do quickly. Doesn't mean it's easy.